Hello all. In this video, we're going to talk about your upcoming stage 2 of your project, which is to design your project. And this is going to go from high level, big pictures, almost storyboarding of what you want your program to do, all the way through the kinds of data that you need to have and down to the point of laying out functions that you need to implement in order to create your program. This is not something you've done before. And there is absolutely no guarantee that you will have this design and then just implement it and there will be no issues. Oftentimes, we have this process where you make a design, you start to implement, you figure something out, you go back to the design and revise it, and so forth. And so, this is meant to help set you up for success. But you just should also be aware that with any kind of open ended project like this, you are going to have to you just have to be aware that you may have to be flexible, that the design may change, that until you're actually implementing, sometimes you don't realize all of the things that you need to think about. In any case, this should help. So let me go to where we can see my notes. So the first set of bullet points here are about why we ask you to do this. So why not just let you jump in and start coding? So for some of you, coding is fun, and just sitting down and starting to code may be something that you enjoy doing. The issue is that as the programs you're trying to implement get larger, if you just start down and start coding, you either create really bad, really ugly code, or you write a bunch of code and can't debug it, or you waste time because you implement things that you then realize you don't actually need or want. So it's taking a moment to think not in code terms, but at a higher level in terms of the overall design, in terms of pseudocode that we've been talking about all semester, that becomes really important. And I've had any number of teams in the past who have gone through this design process and then were amazed at how quickly and easily the implementation stage went. And I've had other teams who didn't really want to do the design process who ended up stuck and having to redo their code. All right, so what are the main reasons that are here? You are working in a team. When you work in a team, sometimes work gets delegated to a team member who goes off on their own to work on that task. If you don't have a clear understanding, a shared understanding in writing of what it is that each piece of your program is supposed to do, you can end up wasting time and effort or building parts of your program that don't fit together because you didn't realize that you needed to be consistent with each other. So everyone has to agree. Making a design document is one way to help make sure that everyone in the team is on the same page. It can also be daunting when you think about writing a bigger program, like let's implement a game, and you haven't ever done this before. You can have a version of writer's block with your programmer's block. You just don't know where to start. By starting with the design, you have built something where you can find the small pieces that you can start implementing, like little helper functions that you know you're going to need that are easy to write on their own. So this is a great reason to have a design document because it allows you to figure out parts that are not so frightening to tackle. And by doing a good design, you'll guarantee that you break the problem down into small enough pieces that you can then tackle each one individually. It will also make coding easier and faster. The design part is like the interesting part, and then turning it into code becomes a sort of routinized part. You can also avoid bad design through haphazard programming. You won't commit to a bad approach and then have to rethink it later. Another goal we have is that you have a really clear and thorough sense of what your program is supposed to do. How is someone going to interact with it? What will it look like? What exactly is going to happen with your program? It's easy to delay that process if you just start coding, and then sometimes you get to the point where you realize you haven't done exactly what you wanted, but now you're kind of committed to a whole lot of code. It's also a good idea to think through which of the features you have in mind are absolutely essential and which ones are maybe optional if you have time. You want to prioritize your work so that you focus on the things that are essential first and you don't build a really cool function that you can't end up integrating into your program. We also want you to think about the information that your program needs, and that means things like data structures. You're going to have some information, say, for a game that you're implementing. What kind of data structures are you going to use to store that information? Are there complicated data structures like images? There will be, because that's a requirement of this project. Are there other things that you're going to have to read in from files that you haven't already figured out how to do? You're going to be asked to break the program into sensible functions, a hierarchy of functions, the main function, and then it has its helpers, and then maybe its helpers have helpers, and on down the line. This is a really helpful design approach. It makes it really easy to actually go ahead and implement the program when you're done. You also want to identify which modules you need for your project. Are you going to use OpenCV, or MediaPipe, or TensorFlow, or some combination of those? Or other libraries that you might possibly need. This can help you to go find documentation and resources that relate to your particular libraries. I'm going to give you an example. This is an example that I have my students in my Intro to Artificial Intelligence class actually work with an implementation. But suppose there's an old game. The details of it are not super important. It's called Hunt the Wumpus. It has many variations. It's one of the oldest computer games ever. It was one of the first games actually defined for any computers. And we want to implement a version of Hunt the Wumpus. Let's suppose that's what we've decided to do. The game has a game board, and it has a certain squares where that the player has been in, and we know what's in them, and it has other squares where the user has not been, and we don't know what's in them. So we need to be able to display that game state to the user. The game board is a two-dimensional grid, and somewhere on the grid there is a wumpus that has been placed, and wherever the wumpus sits, the wumpus is sleeping, and for 2 squares away in every direction there are red stains that mark the presence of the wumpus. If the wumpus wakes up, we lose, so we don't want to wake up the wumpus. There are also a number of pits. These are places that will harm us if we go into them, so we don't know where they are originally. They're going to be randomly placed, but we need to keep track of where they are, and the fact that in the adjacent squares to the pit there is a green slimy marker that indicates to us that there's a pit nearby. So the hero's goal is to figure out where the wumpus is and kill the wumpus from the next room over, and by shooting an arrow. If they miss the wumpus, then they lose. The wumpus wakes up and eats them. So we have to ask the user over and over what direction they want to move or whether they want to fire their arrow. And then we have to update the game to display what happens because of that. We need to keep track of and be able to check whether the user won the game or died or didn't do anything that caused the end of the game. And we need to display the updated map. So all of this describes the game. After this, we would then need to figure out, well, how exactly am I going to represent this information? I need to represent the game board. How would I do that? Now, given what we've learned, there are a couple of things. A 2x2 grid, you could do that as a list with sublists in it. That would be easy. You could also use a NumPy array if you wanted to. Since we're doing vision stuff, maybe if you were doing this, you would represent the game board as in a visual way, not just a logical way. So you'd have like the logical representation of where everything is, but you'd also have a visual representation of it as an image where we maybe draw the wumpus or I don't know, whatever we would draw. Draw the terrible smell, the red markings or the green markings or things like that. So all of those are things that we would want to think through. They tell us, among other things, what the information is that we need to know. We might want to have the pit locations, the wumpus's location, and the hero's location all also stored separately in variables, and those could be just tuples, right? Like row, column, or XY coordinates for the space that the game is playing in. This is the kind of high level design, like thinking through what the game flow is supposed to be like, what are the parts of the game, and then you drill down into what are the data types that are involved in the game, and how am I going to represent the information that I need to. All right, that's just like a very brief example of what we're talking about for the high level design part. What we're going to do after that, we'll ask you to specify the data types, and I've talked about that. We're also going to ask you to do a top-down design of the code in pseudocode. So you don't want to jump into this until you've determined what the program should do and until you've determined what kinds of data you're going to be working with. So, but this is a particular approach to designing code. There are others out there. I think this one works particularly well, especially for early in their career programmers who are still kind of figuring things out. The idea of a top-down design is you start by designing the main function. So what is it that overall you want the program to do from when you start running the program? So you imagine your program starting up. What's the first step going to be? So you have your main algorithm, and the very first step is going to be whatever happens first. And then you have step 2 and step 3, and you just write out in pseudocode at a high level what you want the program to do. And as you're doing that, you think about whether any particular step starts to get complicated. So for instance, maybe you're starting your main program for the Wumpus world. You're going to, when the game starts up, you're going to print a welcome message. Maybe you'll ask the player what their name is, I don't know. And then you need to create the game board. Displaying a welcome message, that might just be a print statement if your program is simple, but it could be something more complicated, like popping up a window with a picture drawn on it and some text overlaid. As soon as you start getting into something where it's like, okay, I'm going to have to create this window with the image, I'm going to have to add the text to it, and then I'm going to have to show it. We have 3 or 4 steps for that one idea of display a welcome message. Maybe what we ought to be doing is making display a welcome message be a helper function. And then all of those details about how we display the welcome message, they go over and they're in that separate function. So anytime you see a high-level step that starts to get complicated, multiple lines in order to perform it, you consider possibly adding a helper function to do that task. Another example would be building the game board. The game board is a little bit complicated to build. We need to place the Wumpus, we need to place pits, we need to place the hero, and unless we want our players to be angry with us, we need to make sure that the player does not spawn in a pit or in the same room with the Wumpus, where the game would end immediately before they have a chance to make any movements at all. That's going to be kind of complicated. The pits have to be generated randomly. We kind of don't want a pit and a Wumpus in the same place, or 2 pits generated in the same place. All of those details at the high level, they're just make a game board. So we call a helper function in our main pseudocode that says make a game board, and then we let all those details go over into that helper function. So this is the general process. Whenever something gets complicated, it goes in a helper. And then you finish describing the entire process, overall process of the game in your main function in pseudocode. And now you know what the overall part of the game is, and you have a list of other helpers that you're going to need to create in order to implement the game. And so those become, if you imagine like a family tree, the main program is your ultimate ancestor, and then all of the helpers that it needs become its children. And then we go and we do the same process for each of them. So if we're generating the game board, we would start writing out step by step what is it that we need to do to make the game board. And if there's a part there that gets complicated, maybe we make another helper. So we can have children and grandchildren and great-grandchildren functions all the way down. They make a tree structure. This is really nice for breaking problems down, figuring out what needs to be done in a separate function. Once we have the entire design, we haven't actually implemented anything yet. But we have this really clear and detailed design. This is the point at which stage 2 of your project ends. That's what you're going to need to hand in for stage 2 of the project, is this high-level description of what your program does, a section that talks about the data structures and data types, kinds of data you need to manage, and then this top-down design hierarchy of functions. As soon as you finish that, you can start implementing, and that is what, and I encourage you to just jump ahead into the implementation once you get here, but this is what you'll need to hand in. Now, let's talk about, once you have this design, how do you go about implementing? And there's sort of some warnings I want to create, like it's really easy once you have the design to be like, oh, well, I'll just turn all of this into pseudocode. And so you just start from pseudocode into code, I mean. So you just start with each function, you start writing it out in Python, and you write out the next one, and you write out the next one. And the next thing you know, you have a page and a half of code, and you haven't run any of it. And you've got your whole program written in Python now. Given your experience thus far, what do you think the chances are that that program is going to run correctly? If you said 0, you'd be right. I've been programming for, oh heavens, 40 years now. And if I ever write a program that's more than one function that just works correctly without requiring any debugging on my part, I like get up and have a little happy dance and cheer. It just doesn't happen very often. We don't write code perfectly. It has to be so precise that it's just a natural part of the process that we have to debug it. So you don't want to generate a whole program, 6, 8, 10 different functions, and you don't know, and none of them work, right? Because then you're looking at the whole program trying to figure out, where is this error happening? Which part of the program is even generating this error? It becomes a really, really difficult task to debug a program like this. So what we're going to recommend to you is that you engage in bottom-up implementation with testing as a part of it. So instead, we design top-down from the main function down to the helpers. Now, when you implement, you're going to start with those bottom helpers, the leaves of your tree. The function that you've specified that doesn't call any other function in your program. Those are the ones you're going to implement first. And for each one, you implement it and you test it. And you test it, and you test it, and you test it until you're sure that it's doing what you think it should do. And then you move on to the next function. And once you have all the children of a helper defined, then you go to work on implementing that helper, because now it can call its children. And you'll have to debug it. In the process, you may discover that the functions don't work well together and you have to go back and revise those other helpers. It happens. But at least at each point, you're testing things and getting rid of most of the bugs before you ever move forward. All right, this is an important part of your task. There's another aspect that will also happen, and that is you realize that you don't quite know how to do something or exactly what parameters you want to use. I'm thinking of, like, suppose you're going to do color tracking as a part of your program. Maybe you need to experiment with color tracking a bit to figure out what color is going to work well for you and exactly what parameters you want to give these different parts of the program that's tracking the color. That's natural. That's normal. And it fits in here mostly because we only really do that. You can do that at any point along the line, but it may end up happening during this bottom-up implementation. It could also happen at the design stage where you're trying to figure out what it is you want your program to do based on experimenting with what you actually can do. So that experimental piece is a part of our projects that you should expect and just work with it wherever it happens. I'm going to end this by showing you a couple of examples of design documents. These are old. These are from many years ago in an earlier version of the Comp 123 course, not our course, but they also did a similar kind of project. And you can look at these on your own, so I'm not going to show you all of them. I'm just going to pick a couple. I chose, when I put together these samples, some examples that were not quite what I was looking for. So you could see what doesn't actually meet our the standard, and where you can also see ones that do. So we'll just start with this first one. So this program is playing a multiplayer version of the card game War. That's where everyone lays down a card, and whoever has the highest value card wins those cards, and your goal is to amass the entire deck. This is one of those children's card games that goes on forever and ever. So the very first thing you see here is the user or viewer's perspective. So this is a description of what it would look like to someone who is playing your game. The program's going to pop up a box that says "Welcome to War." Enter the number of players, and then to begin play, the user will click their deck, and so on and so forth. And it includes a little description of what happens if they win. This is the first thing that you should create. And if it's hard to imagine a user or a viewer for your project just based on the nature of it, then come and talk to me and we'll figure out exactly how to describe what it is you want to have happen here. The next section is their data design, and this was a complicated one because card games have a lot of different kinds of data that we have to represent. So they had piles of cards, which they decided each player has a pile, so they would represent that as a list of cards. Each card was represented using a Python data type called a dictionary. We haven't talked about them, but they're not hard to use if you want. They basically could also be a list where you have like an image for the card, you know its card value, you know its suit, if that's relevant to the game. And then they also listed, they know they're going to need to have some functions here that let them work with cards. So they're going to need to be able to tell whether two cards are the same, which one's bigger, blah, blah, blah. They were also using a tool called Turtle Graphics as one of the things they need, and they know that they need some things to pop up, so they have to learn how to do that. They then have a set of functions. So these are not particularly written in the top-down style. Like there is no main function right here. Num of players is an early step, but it's not the whole program. So they kind of didn't quite hit the mark there, and you can see that I say that they need some more of the helpers, but this is actually relatively fine. It's rough pseudocode, but it's clear what the steps are, and then they have the helper functions they just did as sort of indented as a way of showing what was happening. All right, so that's one example. Here's some people playing Go Fish. They described the game as just a big piece of text. That's fine. I would prefer they actually broke it into paragraphs because that's a kind of a wall of text, but it was okay. They did talk about what the variables were they would need for the game. They would have to represent each card. They would have to figure out, store some things in lists, and they had images that they were going to use, and then they have a function design. So they have the overall steps, that's the main program, and then they have each of the helper functions. I think in this one, I took them to task because it wasn't always obvious what the helper functions were. They just kind of had this hierarchy of things that needed to happen. So they hadn't quite done what I wanted, which is to list functions. Let's see if I can find one that does do that. This was an obstacle game, so they have a ball that has to jump over obstacles, I believe. So this, again, they have a paragraph-style description of what the game is going to entail. They have a data design section where they talk about the different kinds of data that they're working with and how they're going to get the data into their program and so forth. And then they have a function design. They have a main menu, which is they were building something with graphical user interface, so they have a main menu as a way to get into the game. They have the game design, which shows what's actually happening, and then some other functions: jump function, jump side, collision, and so forth. And that was pretty much fine for this particular project. So I want you to see throughout all of this that there are different things that students have done in the past. There's some nice examples for you, and what we're looking for is something like what these have written. You can have a bullet point description of what your program does, or you can write it out in paragraphs. As long as it's there, as long as the content is there, it'll be fine either way. This is not a writing assignment. I want it to be readable, but I don't. Beyond that, I'm not going to grade it as formal writing. It's a design document. I want it to make sense to you. So this is what we're looking for. Design is important. You need to be thinking about it. So if you have other questions, if you want me to talk through the design with you, just make an appointment, come to see me, grab me in class, and we will do that. And I will see you all very soon.